Hi guys, I'm Sajjad Rezvani. I'm 24 years old. I've finished my electrical engineering bachelor degree from Shaykh University. I'm programming from 10 years ago when I learned C++ programming in high school, and then I continued and learned other programming languages and algorithm and other stuff in computer engineering. And now I'm programming in a company from 3 years ago as a Python developer, and mainly I like to program in machine learning and neuroscience. I've also learned several courses in university as teaching assistant, um, such as machine learning, signal processing, and math and physics. In these sessions, we are talking about AutoGrad, backpropagation, and let's move on to the topics. Let me share my screen. So here we want to talk about PyTorch AutoGrad. First of all, I like to mention about the concept of backpropagation and what happens in backpropagation, and then we can have this section, which is the coding. As you remember, we had something gradient descent when we have an optimization process and we want to find the best weights of the regression model or also deep learning model in neural network. You had a gradient descent that in this process you have some derivation. As you see, you have a run j to run the omega. But when you have a more complex function, let me show you the other picture. Yeah, for example, in gradient descent, simple gradient descent, you have this function and you had this grad to find this slope of the curve, and after multiplexing with learning rate, you actually have minus to x minus learning rate to grad. But when you have actually neural network or you have a more complex function, such as this picture, that you have several elements, several factors in this function, such as b and omega, which your derivation is based on these elements. And you have other stuff, like, for example, ReLU, which is an activation function. Your derivation become more complex, and this is when something happens. We use something as backpropagation. And in this function, you need to calculate the derivation of the result of activation function, which is a, based on the elements of the input, which was b and omega. And you have something else in the middle of this process. So you have a two-step derivation. And as you see, you have dr to dv and then dv to dv. So this is the concept of backpropagation. And in this process, you need to actually calculate the derivation step by step. But in some libraries like PyTorch, they automatically calculate this derivation using AutoGrad, which this guy mentioned, automatic differentiation. The magic of automatic differentiation is the point of that it's become very more easily. So as you see, this is the graph, computational graph of this, for example, process when you have the inputs of x and parameter omega and b, and you should calculate loss using this gradient actually in backpropagation. So we have this code which we need calculate forward and backward propagation. Actually, you don't need to calculate backpropagation. As I explained, we use AutoGrad, but for forward process or forward propagation, we need to code it. We use torch.tanh as activation function, and here you should use. Let me comment this line. Yeah, you should use x dot self to omega, self in omega, plus self dot omega and self dot b. So here we calculate the output of this function. It's exactly like regular regression, simple linear regression, I mean. So after that, in this way, you calculate the output or your prediction. And in next function, you should calculate the loss function using this y to do and y prediction, which comes from the previous function. So you should calculate. Let me check the time. Yeah, I have a minute more. You should calculate the y true minus y prediction, and then you have to use a square. It's a simple loss function, MSE actually, that we had previously in other sections, such as linear regression. And then we can run this code, and this code successfully calculate the forward propagation, which is calculating prediction, and after that loss. And in other sections, you will see that using this loss, we can calculate actually derivation, as I mentioned, for back propagation using AutoGrad to successfully train this actually network. Thank you very much.